Artificial intelligence is changing literally every part of human life. I mean, today I came from my house in Campbell, California, to VMware's headquarters here in Palo Alto, where I'm taking this video. And my lunch was prepared by my oven, June oven, that has an NVIDIA card in it and a camera. And you put a piece of toast in it, it says, "Oh, that's toast," and cooks it to the right temperature. On the way here, Spotify used an AI to pick the music on Discovery Weekly's playlist. And my Tesla drove me here. 99% of the driving on the way here, I didn't touch the steering wheel or stop at stoplights. And AI is starting to come along with the autonomous cars, which, by the way, are done right across the street here at Tesla's R&D factory. But VMware saw my latest book on spatial computing that I co-wrote with Irina Cronin. And spatial computing's augmented reality glasses, and robots, and autonomous cars, all working to change our lives deeply. And we wrote about 7 industries that are going to radically change over the next decade because of this. And AI runs all that. So VMware invited me to talk a little bit about that today and interview one of its AI experts. And let's dive into that interview right now. The reason we're doing it, next week, VMworld, 100,000 people are going to be online learning about the latest in technology that runs the world's business from this great company, VMware. So it's an honor being on the call with you. You know, Eric, I was thinking just about how deeply our lives have already changed because of AI. I mean, my lunch today was made by a June oven, which has an NVIDIA card in the oven and a camera. And you put a piece of toast in the oven and it says, "Oh, that's toast." And it just starts cooking it, right?
Image recognition at work there, yeah.
It's awesome, right? And on the way here, I was listening to Spotify's Discover Weekly playlist. And I met the guy who built the AI for that. So I know that's AI that's picking my music. And of course, I'm sitting in a Tesla, and Tesla's a block. Their R&D lab here is right across the street from. I'm sitting in front of VMware in Palo Alto, California. By the way, I came and trying to get some pictures and stuff for the posts I'm going to do with you all over the next few days to get ready for VMworld, which is going to be virtualized for the first time because of COVID this year.
Yes.
Right? And last year you had tens of thousands of people, and I don't know if we should reveal the number, but I hear it's pretty close to 100,000 attendees right now signed
That's
up
amazing.
for.
I know for a fact we can talk about it. I mentioned in my podcast that we exceeded the 100,000 mark right now, and we're still a week away. So definitely really good numbers coming in.
And I'm sitting, to continue this theme of how AI is changing your life. I'm sitting in this Tesla, and it self-drove me 99% from Campbell to here. It was self-driving. It stopped at stoplights. It changed lanes automatically, all because of AI, right?
Right.
And when it's funny walking down the road here. I remember visiting here 13 years ago or something like that when I was a journalist and blogger. And I met with the founders of VMware and got a look at some of their early products and where they were going. And now, of course, it's turned into a major company that runs so many of the world's businesses, right? And does so many different things, from security to management of computer systems and data centers to virtualized machines, so you can run all sorts of different kinds of operating systems, either in the data center or on your local machine, right?
Right.
And I just finished this book about spatial computing, which is how autonomous cars and robots and virtual beings, like we're soon going to meet virtual beings, which is a whole separate conversation. And all of this new stuff coming in augmented reality glasses. I mean, yesterday Facebook was showing off prototypes that they're wearing around with 7 cameras on there and AI chips to recognize things in the world, right, and be able to talk to the computing system. So our computers are about to really radically change, and our businesses are radically going to change over the next few years. And that's what my book was about. And that's what led me to talking to you. It's like
That's great.
VMware wanted me to talk a little bit about some of the things that is going to be discussed at VMworld in a week.
Right.
And everywhere I turn, I see AI everywhere.
You can't escape it now. Yes, yes.
No,
They're taking over.
and soon consumers are really going to understand that. I mean, I'm an early adopter of June Evans and Tesla cars and Spotify, and I've been around and I understand how these things are built. But soon you're going to be wearing a pair of glasses and everything is going to be AI, right? So
Potentially.
So
That car that you're in, I believe, has 17 different neural networks operating in different chips, reading the sensor data and deciding, is this a stop sign? Is this car getting too close to me? All kinds of predictions going on in the car itself. And it's really fascinating how it's pervaded the world so quickly,
yeah.
But yeah.
So who are you? Just to introduce you to the audience, because my audience, first of all, my audience probably doesn't know VMware very well. They probably heard the term on CNBC or something, the company, but they don't know what you guys do, because unless you're working in IT or data centers, you probably don't have a good idea of what VMware is. And then my audience probably doesn't know who you guys are. So who are you?
Well, I'm Justin Murray. I've been at VMware 14 years now. I joined when VMware vSphere was young. And I've moved through a series of roles, mainly in technical marketing, which have to do with emerging technologies. A couple of years ago, it was big data, but now very much in the last 3 or 4 years, it's been machine learning and GPUs in particular. And there's a very tactical answer I could give, which is customers want to know how to use GPUs the best way on vSphere, but the field is much, much bigger than that. I think I'm interested in helping customers understand how to do machine learning with VMware as the operating system kind of thing. And it is becoming the operating system for all kinds of clouds. AWS has it, Google has it, IBM has it. It's not just an operating system for on-premises data centers anymore. But what fascinates me, like you, is the amount of innovation and uses that are going on. Like I've been dealing with medical images for the past few months here, and detecting COVID or non-COVID in those images using a machine learning model, which is, that's not in the doctor's office yet, but it is in the research institutes in the NIH. And,
when I went to Israel, I met a company, Zebra Imaging, that can see cancers in X-rays and MRIs, and it's more accurate than the doctors at seeing certain things, right?
More accurate than the human, exactly.
And AI is a pattern recognizer, right?
Exactly.
I mean,
exactly.
And so if you teach it to see a certain kind of cancer, it just as soon as it sees that pattern, it goes, that's that cancer, right?
And the reasonable thing about it is it will give you a probability that it is, or a probability that it's not. It's not giving you a 1 or a 0. It's giving you a 90% probability, or 0.9 or 0.1 probability. So it's being a little cagey about its decision, and so there is a need for human decision makers in the loop, is what we've learned, that this thing can't take over our jobs completely. It's not quite there, but it's getting closer and closer. And, voice recognition, image recognition. And the way I explain it to my customers and my colleagues is, business intelligence that you've been doing for years. You've been generating reports and SQL statements against your massive amounts of databases. Well, that's kind of reporting on today's situation, or last week's situation, or last month's situation. ML is different. ML has in common with that, or machine learning has in common with that, there's a big chunk of data that you can throw at it. But it's not about reporting on what's happening right now. It's about predicting what's going to happen in the next minute or second or hour or day. And that's that's really the interesting thing is it's future looking. It's trying to tell you ahead of time what the patterns of data and the past data have told it.
Yeah.
And the bugbear of all that is, you know, is the past able to establish the patterns actually that are going to occur in the future? Could we have predicted in January that we'd all be working outside the office for the
No.
6 months, for March onwards? You know that, and so in reality, patterns in data are changing all the time, and so past data is only to be trusted for a certain period of time as giving you the indicators of patterns in it. And
Yeah.
so you need to constantly refresh and redo your training being that part of the machine learning that applies the data to a training algorithm.
And we should talk about training because I've already seen a new trend that the cost of training a new system it is coming down. It's almost like a Moore's law. It's coming down exponentially,
Right,
and it's becoming faster to train things, right?
right.
And here's where I was going with this. I was talking to the guy who runs augmented reality at Trimble, which is a construction company, and they're buying these robot dogs from Boston Scientific that you might have seen on YouTube, right? The little dogs, and the dogs walk through the construction site and image it with a lidar, so it's
Huh.
imaging it in 3D, and then the AI looks for safety problems, things
Interesting.
that things that might hurt a human tomorrow. Like you said,
Yep.
prediction, right?
Prediction.
This car is predicting a kid is going to walk in front of it, so it slams on the brakes, right? So,
Right.
and it's always trying to predict what's the next action of things on the street to threaten the car. But this can mean a lot of things to all sorts of businesses, from retail stores to construction companies, right?
Correct. Correct. The simple example is you bought, I'm being old fashioned here, but you bought album A. So you might be
I
interested.
remember those days. I'm
You remember
55. So
albums.
yeah, there's
Yeah.
big things that are plastic, they're vinyl.
Weren't they wonderful though?
You
Weren't
put
they
them on
wonderful?
a record player and put a needle in them. It's like
They were
what?
works of art, right? But you streamed program A, so you'll be interested in streaming program B, recommendation engines. And engines are a huge industry in themselves. You know, whole teams of software building those things. And that's the simple example. But the slightly different example is, okay, you're at a checkout in the store, whenever you go to a store these days.
Wait, time out. You already using old terminology. Checkout.
Right,
At Amazon, there's not a checkout. You just grab a bag
right.
of chips and walk out of the store because the camera is
There's a
watching
camera.
you, picking you up, yeah, and a 3D sensor and maybe some other things watching you shop. My best friend is doing R&D in the retail industry, and they're forbidding him to use the term checkout. There's not going to be a checkout in the
There's not a
future.
checkout. I've been through one of those Amazon stores, I think in
You
Seattle.
like to talk about old things. I already noticed that. Vinyl and checkout counters.
Yes, yes. Well, drawing examples purely, but the one I was going to give was, if somebody faked the barcode and took a cheap barcode and put it on an expensive item, the only way around that is for a camera to tell it, hey, that's a $4,000 bike that he's selling for $20 here. You know, it's that's actually a real use case that we've come across. So
Yeah.
there are
There was a company I met who uh, can take a picture of a driver's license and know whether the driver's license is real and has been modified,
wow,
right? By the pattern in the plastic on the driver's license, right? So
yeah.
yeah, you're right. It's endless. There's not going to be a part of human life that's not touched by AI soon, if already.
Yeah, and I'm fascinated by that tension between the business world is full of tabular data that comes in
Yeah,
tables, and
yeah.
the
Like a
exciting,
spreadsheet.
yeah, the exciting ML world is full of images and voice recognition and stuff that has nothing to do with tables.
Yeah,
Now, I used to be confident in my view that you need to accelerate the latter workload. You need to throw as much GPU and hardware at it as you can because it's doing neural networks. They're heavily compute intensive. And you don't need that for tabular data. But I'm not so confident in that view anymore because
why not?
I see all those companies that make their living out of ML for tabular data, you know, Salesforce, lots of other companies, smaller companies like H2O and Data Robot, the vendors in this world, they're now adopting GPUs as fast as they can.
Yeah.
And now you're seeing traditional tabular models like XGBoost, that's been famous for a long time in the tabular world. You're seeing that getting accelerated by GPUs and Spark. And I just came off a project where we applied Spark with GPUs to XGBoost and got a huge boost in performance. You know, where last year, the year before, I would have said to you, you can do that with regular processors. You don't need any special hardware for this. The specialized hardware that's popping up all over in this ML world is really fascinating. You know, they're going to be.
In fact, my Tesla had an NVIDIA card when I bought it, and they took that card out a few months ago and put a Tesla-built AI chip that has 18 billion transistors in it, right? So there's an Apple just announced a new iPad with AI capabilities built into a piece of the GPU, right? Why, for people who don't know this new world and are coming into it, why is GPU so used? That I keep hearing this all over. You know that this is why NVIDIA stock price keeps going crazy, right? So,
oh yeah, it's and they're now purchasing yet another company. Yeah. So the G in GPU, as you know, stands for graphics. So these devices were intended to accelerate rendering and shadowing and ray tracing on sophisticated workstations for AutoCAD and that sort of thing 10 years ago or more. And they've been hugely successful in that. Yeah. But what was going on under the covers there is that matrices were being multiplied by other matrices at high speed. And those matrices indicated coordinates in the graphics. Somebody who is very smart said, what's happening inside a neural network, a collection of modules that are strung together in a network? That's exactly the same thing. It's multiplying a matrix of weights by a matrix of inputs, matrix multiplication. Where does that operate the best? It operates on parallel processors, parallel cores, because you can do all of the layers in the neural network, all of the nodes in the layers at one time in parallel. So a very bright person said, let's apply this to executing neural networks, and got a 10x or 50x performance increase. And that's why GPUs are being talked about so much, but they're not alone. You know, GPUs can be tied into fast networking such that a GPU can talk to another GPU over the network without going through the CPU, without going through the main memory of the CPU. And that's an experiment that we've been doing and using it in clusters so that the type of data scientist that needs more than one GPU to do their work can get it from the other side of the network without having to.
Somebody doing simulations, really in-depth simulations of chemistry or physics or military or
or Uber.
Caring about some crazy stuff. Yeah, true. Yeah.
Uber and Twitter, who went to the trouble of inventing distributed frameworks to get the best out of, you know, they've got 300 or 400 GPUs spread across their data center, and they're utilizing them at 50% or less. And so,
and that brings us to VMware.
Exactly.
Right. VMware, for people who don't know the history of VMware, you know, back in the old days, businesses had to buy a rack of their own computers and set them up in their own data center, right? It was really expensive. Yeah. And VMware and a few other companies comes along and goes, hey, we can split that machine up into virtual pieces, right?
Right.
So that we can rent piece one to this company and piece two to this company. And that's cloud computing today, right?
Exactly.
And VMware was the software that did that, right? And
we're doing that
so
with GPUs now.
So you guys are doing the same thing now for GPUs.
With NVIDIA, yes, we are.
Yeah.
And, you know, I'm kind of surprised and delighted in a way that NVIDIA is helping us with this. They invented the concept of virtual GPU, which allows you to do exactly for GPUs, what we've been doing for CPUs for a long time.
Yeah.
And that's kind of method two.
And I think I have a thesis, and it'll be interesting to talk to you about this thesis. GPU training something, right? If I'm going to train this car to see a stop sign, I have to take a lot of pictures of stop sign or video. I have to tag it, And then I have to throw it into a training system that runs a lot of GPU for a short period of time to build the training set that it runs the car, that gets uploaded to the car and runs the car, right?
Or train it for a long period of time too. Yeah.
But it's bursty. You don't need it all the. It's not like Twitter, where the stream of information going through Twitter every day is pretty much the same all the time, 24 hours a day.
Right.
When I'm working at Tesla, one day I'll probably have a really big training problem, and the next day a little training problem, right? And I'm not using the same amount of GPU every day. Well, why would I want to buy my own GPUs in such a world? Rent them from somebody like Amazon or Google or NVidia or right? And I bet that's why they're talking to VMware, because VMware enables that whole process.
Correct. That's absolutely right. And yeah, you're right that there is lots of bursty use. Some of the customers we've looked at are 50% or less usage. When you need it all, but you don't need it.
You need more
all of the time.
If you're gonna, like, Tesla's data set is getting pretty sizable now, right? So if you're gonna retrain on new images that worldwide with 1 million cars, that training set can get pretty crazy, and you want to throw as many GPUs at that problem as possible to build that training set and then upload that to the cars, right?
Correct. And you have 17 or more of these neural networks being trained at once. That's a lot of power you need there. So you need to be able to commandeer power when you need it and then relinquish it when you don't. And that's a VMware problem.
I think it's funny that Tesla's R&D lab is right across the street from VMware. I'm sitting in VMware in Palo Alto, and literally across the street is Tesla and Pivotal, which is another cloud computing company.
I know that building. I know that building. Yes, they're right there in Deer Creek. Yes, yeah. They're an advanced user of all this for sure, and they're some of the leading lights in the ML world work for them. We've had some of them to speak to us at VMware, in fact. But
I met some
I think of it
as they steal lunch from your cafeteria here. Before COVID, they'd come across the street and eat lunch at the cafeteria.
We have the best cafeteria for sure. Well, we're into sharing. We're into sharing. We see people from Uber and Tesla.
I hinted at it before that the cost of training is coming down, and partly because you can rent servers and not have to buy a lot of servers, right? Not have to buy a lot of GPU, and you can scale it up to the workload that you have, and if the workload gets bigger, you can do that. What's happening in your view? What are the trends that maybe a little bit? What are you guys going to talk about next week at VMworld, and what's happening that you're seeing that maybe people don't know about? In terms of the cost of these things and the capabilities.
There are a whole bunch of things happening, a whole bunch. NVIDIA, for example, acquired Mellanox. Now, why does a GPU company acquire a networking company? Because...
Well, you give the hint.
Exactly.
To hook them up together fast, right?
To hook them up fast, exactly, so that it looks like one big computer, but in fact it's distributed around. And so distribution is going to be a key theme in this machine learning world. And it hasn't really hit there yet because distributed training is a hard problem. Distributed training involves swapping all those weights that we're adjusting in the neural network between all the participants at intervals during the training process. And so Horovod was invented by Uber to do just that. It was a refinement of something Google had already done, but that's really in its early days, that whole distributed training business. The majors have figured it out, but it hasn't pervaded the rest of the industry yet. So that sort of distributed stuff is coming. Along with that, what you were saying, which is dedicated hardware that is designed for training or designed for inference, that's coming too. Companies like GraphCore are building specific hardware and ASICs for executing training better than anybody else. And you can see Google thinking about this with TPUs. And NVIDIA has a range of products now, one of which, T4, is destined for inference, whereas the A100, which just appeared on the market, the new high-end machine, which has sharing in it, by the way, built into it, That's for training. That's the high end is for training. So people are when people start customizing the hardware to specific software needs, you know you're onto something important here, you know.
Yeah.
So those two themes I think are going to be very big: distributed operations and custom hardware. Um, what is fascinating to me is the pruning of the neural network tree, if you like, to optimize it. So neural networks can have 150 layers in them with 1,000 nodes in each layer or 500 nodes in each layer. They can be huge. They might not fit on one GPU in the memory of a GPU. So a whole bunch of academic research is going into, do we really need all those layers? And do we need the layers in a tree shape or in a curved shape, or what shape is best? And there's an interesting paper from a whole bunch of Google folks, including Jeff Dean, the guy behind a lot of innovations there, on where is the best location to place layer 1 as opposed to layer 2 and layer 3 and layer 4 as far as a GPU layout is concerned. So this is not there yet as far as mainstream is concerned, but it turns out that you can find patterns using machine learning itself as to where the best placement of the individual layers within a neural network should be.
Wow. So the AI is making the AI smarter.
There you go.
Or more efficient, which
there
efficiency is going to matter, right?
We've turned it on itself now. Yeah. So if we've got a problem to solve, which is where is the best combination of GPUs to execute these 150 layers or a pruned version of that, why can't AI give us the answer, having viewed a whole bunch of neural networks histories in the past?
I would expect VMware is using AI all sorts of places, particularly with its multi-cloud systems, right? Because when I built websites, I'd buy a machine and put it in a rack somewhere, right? That's what I used to work at Rackspace. That's where they got their name from, right? But now,
yeah,
why doesn't an AI decide where to put that in a virtualized machine and maybe even move it around, you know, depending on price or speed or closeness to the customer? I mean, if I'm playing augmented reality games, I want those packets to be really close to me, so the virtual machine should move closer and closer and closer to me to have less latency and stuff like that. Right?
You're exactly right. Traditionally at VMware, we call that distributed resource scheduling, which is suiting the workload to the layout of the hardware that we've got under our control. And we've been looking at algorithms for that for years. But you raise a broader point, which is, can VMware improve its products using AI or machine learning? And we're full of really smart engineers at VMware, so they're all looking at that very closely. And the ideas are, we have internal innovation conferences where the ideas just flow like crazy about that. So there's a whole bunch of things in the pipe for exploiting machine learning for our own products, as well as helping customers, you know, do their machine learning as well and make their businesses better. So there's kind of a three-legged stool here, three angles to ML, one of which is improving our own products. Another is improving our own business, like setting pricing based on ML for our products. Yeah. That's done today using ML.
That's smart.
And then applying it to business situations that customers have, like fraud detection in banking or in healthcare, like we mentioned, or a whole bunch of different businesses. I'd read recently that something like 40 to 50% of the new Kubernetes applications will have some element of machine learning in them.
Yeah, it's not crazy.
It's a huge portion.
Yeah.
So
agileness, I mean, some of this was is to build new kinds of products. I mean, and there's some commonalities. My iPhone, my Tesla car, and my June oven all have improved after I bought them. They got better, right?
Yeah, yeah.
And in a big part because of AI, AI lets you build exponential learning systems that get better over time and learn as they learn more about the tasks that they're trying to do, like cook toast.
Right.
They get better, and they get better for everybody who has a June oven, because some engineer at June trains it better to see different kinds of toast, and all of a sudden everybody's oven does more, right?
Improves.
After
Improves.
it improves, but my Tesla car changes lanes today. It didn't do that when I bought it, right?
Right.
You know, and
It's great.
so
Yeah.
it is amazing, right? And it totally changes. Auto industry is having to react to, you know, these ideas, right? Because
Right.
now it's the expectation. When I bought a BMW or Toyota, I never expected it to improve after I bought it, right?
Exactly.
Now I do. The next car better have that already built in. That, you know, I mean, my it's so deep that my brakes have improved because they downloaded to the car new algorithms to work the brakes better, right?
Adjust the brakes. Adjust the brakes.
It,
Yeah.
and even like I'm using a little gimbal, right, which has 3 little motors in it. It's a $128 DJI. It's using AI to figure out how to turn the motors to keep my iPhone steady. Right?
Well, you raise an interesting subject here, which is how small can we make this? How small a device can we fit this into?
Yeah.
And now you're beginning to see why NVIDIA is interested in ARM, because it could be the case that the actual big money here is in the inference phase, not the training phase. Now we've made lots of money on training so far because that consumes gigantic machines with lots of GPUs in them. But how many millions or billions of devices like your gimbal or your control panel in your car are going to be
security camera at the door here, right?
correct?
I'm at on and on and on, right?
So
Factory floors are being digitized in a whole new way with a process called digital twinning. Volkswagen told me about this, and they're using AI on the factory floor to design the factory floor. So it's crazy. It's endless.
super interesting. But the challenge for us techies is how much memory can we put in that low powered device to hold
Yes.
the trained network, and how fast can we make it? So how small can we make it? And
and how battery efficient, right?
yeah. And Google came out with an experiment not so long ago, which said all of our cell phones that we're carrying around with us, why couldn't they be participants in a federated, distributed training exercise where the phone is in charge of its own data. The data doesn't go anywhere, but the data is being used to train a model. That trained model is then sent back up to Google and amalgamated with all the others to make one super trained model. Now that's a fascinating idea, that you federate the job out to every phone user that you know, and the results come back in miniature form from the device. They've used local data like what sites has Justin visited on his phone recently. And we can train a central model based on all that data. So this is federated and distributed at the same time. You know, it's this is the new renaissance in computer science. This is the flower of business here.
It's endless and you know, yesterday Facebook was showing off these prototypes that they're going to have a few hundred workers walking around with 7 cameras and a AI chip inside that and a LiDAR, right? So that it recognizes the world and recognizes everything you touch and everything you look at. And they're trying to figure out the privacy implications of that and how you know what they have to do to keep from freaking people out, because we can go into Black Mirror land real fast, right?
Yes.
But what you just said with Google, if I'm touching a Coke can in a grocery store, and I teach it something new about Coke by talking to it, that's going to want to be shared by everybody else, right?
Yeah.
And so that it recognizes, oh, there's a new Coke can maybe for Christmas or something just showed up, you know?
Yeah. There's a lot of possibilities here. On a more mundane level, customers have come to us like airports and have said, the cameras are feeding video data back to a central data center somewhere. We want to be able to tell immediately if somebody's in a place they shouldn't be. We want to be able to do surveillance using machine learning. And there are companies now that specialize in that. And, you know, there's a whole security angle to this. And there's
totally.
There's a business angle to it as well.
There's a what?
there is a bias angle to it in the sense that have I trained my model on a representative set of images or people
Yes.
even?
Yes.
Is this a fair model to women and minorities? Or is it
Yes.
biased in the favor of us guys who do tech? You know, it's
Yeah.
uh,
And it, because of the training, you can sometimes pick up wrong thing, or you can pick up patterns that shouldn't be, right?
right,
Racism is a pattern that shouldn't be. We want to get rid of racism in the world, right? And make things more fair. But if you look at home buying behavior, right, your AI might pick up a pattern
right,
that shouldn't be,
right,
right?
right.
And then all of a sudden it reinforces that pattern in the future on people. And that's a bad thing. I assume you're going to have some ethics discussion, many ethics discussions. And
There is a whole
uh,
field of discussion going on around that. How do we introduce fairness and prevent bias
yeah,
in the machine learning training phase? It's a
here's
hot.
what I was at the data science conference one time, and the founder of Turo, which Apple bought, was giving a talk, and he said, you know, we had a problem one day. We were training AI to see wolf and husky, right? And we went through thousands of photos teaching it how to see wolf and husky. And he said it after the training was done and they started running the system, it made an occasional weird error. And this thing should never give an error, right?
Yeah,
And they had to unpack the training data that it builds, right? The neural network that it builds.
right,
And they said what was funny is it started learning on, is there snow or grass in the photo? It wasn't even looking at the dog or the you know
right.
the husky or the wolf. It was looking at, is there snow in the picture, which was usually accurate because a husky is usually on snow and a wolf is usually on grass. But once in a while, they would switch and be, and it would throw an error, and it learned on the wrong thing. And he said we had to remove the snow and the grass from the pictures to retrain on the dog's face, and on the dog,
Interesting.
on the wolf. And
Interesting.
that's a very simple idea now, but this stuff still happens at a big scale. So if you're a business, you really have to have experts who really think through what kind of data you're going to teach it, right? What are you going to
Precisely.
teach it?
Precisely. And you put your finger on something in that discussion that's extremely important, which is if I'm a person working in a bank and I'm in charge of recommending somebody gets a loan or doesn't get a loan, I'd better be able to explain my decision making to a regulator. And explaining what a neural network is doing is tough. It's really tough.
Yeah.
Unraveling a neural network is, an almost insurmountable problem. And so we've heard of situations where unless it can be explained as to what it's doing, unless it can explain what the most important weightings and the most important columns in the data are, then it's not going into production because we can't explain ourselves to the regulator for that reason. And so there's a whole field of interpretability being researched, and actually companies like H2O and others are quite mature in that world. By building a simpler model that you can explain that produces a very close result to the sophisticated model, you can
Wow.
say, by correlation, I can explain the simpler model to you. And so the more intense and sophisticated model is doing the right thing because they came up with the same answer.
Oh,
That sort of interpretability idea needs to be solid before this can go mainstream in many businesses. And
yeah.
you can
Well,
take
I've
that.
taken 40. We planned on 20 minutes of discussion, discussing AI.
I had
You
no
can go
idea
for
what the
hours
time
and
was.
hours.
I had no
Yeah,
idea.
yeah.
Sorry about that. I didn't get into
No,
my.
no. I just it's such a big topic. We could go for hours and hours. And at VMworld, I'm sure you'll have several sessions on different
We do.
topics we covered today.
We do.
There's hundreds of sessions, right, for
Yeah.
people to watch on
If you're
video.
if you were looking for the theme, I think in the VMware sessions, there's lots of stuff about innovation, but if you're looking
Yeah.
for the theme, it's VMware providing the infrastructure for machine learning rather than providing the application logic itself. We have that, and we've built our own and done it for ourselves in our business. But I think our core competency is how do we optimize the infrastructure, partly to do with sharing, but partly to do with dedicating as well, so that the data scientist is happy without even knowing they're on a virtual machine. You know,
Well, thank you.
that's the core competency here. That's what we need to get right.
Yeah.
So
Well,
that's,
thanks for spending some time. I could talk to you all day long because
yeah, likewise.
you're
Thank you.
in the middle of it.
I'm in a very
Middle
lucky
of,
place. I'm having the best time of my life here. You know.
yeah. Well, thank you.
Thank you. Yeah. Have a good afternoon.
Yeah. All right, we'll end there.
And
And I'll
call
cut
again
it off.
if you need some more on this. I'd be
No,
happy.
this is cool. I just talk to people like you to understand how where are shifts that I don't see coming, you know, and where, like, you give me some insights on inferencing as splitting apart, and visibility of these neural networks is also another thing that's coming along. I had heard that, but
Yeah.
yeah.
To Justin is if we look at the explosion in AI, right? And I look at the web apps that came along, and then I look at IoT, and my thermostat has a computer in it now. But now everything is exploding into, not only do you have to have a computer in almost everything, but now your computer has to think. And to our point where you don't have the horsepower in the device itself, it means you connect it to a very fast net back to somewhere. And then everybody that's building apps have to now not only have to worry about their app and their web app and the interface to the IoT device and the network speed, you also have to worry about back-end vGPU capacity to provide the necessary horsepower to do this work, right?
Right.
Yeah.
Right. And you're absolutely right, Eric. And when you're building the app now for the device, the question you're asking yourself is, how can this app learn? How can it learn from the patterns it's seeing, and how can it do better as a result of that learning, which is, I think, what Robert was saying about his car.
Yeah. Well, how can you collect data that then you learn with, right? And that's a big one. That's a big one. A lot of businesses have to really rethink themselves. Like, what do we need to start collecting to be able to build a training set, to build a system that learns?
And Tesla must be thinking, why can't Robert's Tesla learn by itself as opposed to sending data back to us to do it all centrally? Why doesn't learning take place? And learning is an active verb in machine learning. Why doesn't it take place in the car itself? You know, and just send us the results.
For me, pinning it back to VMware, you've already got a ton of infrastructure that does the web computing, that does the connecting the networks and talking to the IoT device. And so VMware coming in going, hey, and by the way, we can just extend our infrastructure to give you vGPUs and allow you to extend your application into this space makes a lot of sense, because instead of needing to rack more hardware, you know, we can give you that layer that can connect to all the clouds. And that to me is like the ability to scale out to meet this demand is going to be one of the big IT challenges, right? It's just scale the infrastructure to do this. And hey, guess what? We're investing in the ability to manage your vGPUs and allow you to manage all this and scale it out.
Well, my friend right now is up in a Microsoft data center putting in GPUs, and he says these data centers are so massive compared to what I was looking at when I worked at Rackspace. He said some of them are almost a mile long and just shoved with machines, right? And they're putting a lot of NVIDIA cards into them, he says. So you can see, I mean, that's just one company buying the stuff, right? And I'm sure Google and Amazon are doing the same thing, you know, just buying a crap load of these NVIDIA GPUs and hooking them up.
And if that's going to be a cloud data center, you can bet that Microsoft will be carving up the GPUs and giving you half and me half, or, you know, a third each between the three of us. It's not the case that they're going to dedicate the whole device to one of us, unless we pay the premium. But so I look back at the history just yesterday, and since 2013, we've been doing vGPUs at VMware for graphical reasons, to share the GPU among graphical applications.
Yeah.
So it's only been a year or two, maybe 2 years, that we've been using those same vGPU concepts for compute, for heavy duty neural networks. So that, you know, a lot of our customers have GPUs for reasons that are not machine learning, But by nighttime, when they're not using them for their desktops or workstations, they could switch those over into machine learning quite easily. You know,
Yeah.
that's
Oh,
another
that's
thing.
interesting. That's actually interesting. You know, uh, NVIDIA just came out with the 3080 card this morning, and that's like a supercomputer. It is a supercomputer, really. You know, and if you're buying this for a VR company, right? You have a lot of GPU just sitting in people's desktop, unused at night, and
Correct.
you guys could come in with a layer and say, "Hey, we can use all that," right?
We call it desktop by day, machine learning by night. We have a whole theme of
Oh, that's
guys
interesting.
looking at that. So
That's
yeah,
interesting.
yeah. Because
Cool.
all you have to do is switch the vGPU type from graphics intensive to compute intensive, and off you go. The same device can be used for the new purpose.
That's cool.
Yeah.
That's cool. Can mine some Bitcoin too, right?
We used to do that, but now we've turned to machine learning instead.
No, I got actually. If I remember right, somebody wrote an AI to sense whether somebody is cheating and cheating the clouds and using the GPUs for Bitcoin mining because they don't want that workload.
I think it influenced revenue for a little while, but
Yeah.
the shine has gone off there, I think.
Yeah. Well, cool. It's been an honor talking to you. I've
Likewise,
learned a
thank
lot.
you. Thank you for spending
Hopefully,
time.
hopefully this comes out. Send me the recording and I'll chop it up. And I'm gonna go do another intro in front of the sign and put that in. So
Fantastic. Sounds like you're on a plan. Love it, and can't wait to get it in market. So, Justin, thanks a lot again for taking time out. You're just amazing as always, and
Thank
great
you.
series. We will stop recording now.